Good. Some organizational information to start from. So as you know, we are going back offline. The lectures remain online, unfortunately, because there are too many, the groups are too big to have offline meetings so far, but seminars would be offline. So you will meet Vladislav here in the school. There are some numbers, very limited number of students who remains online, mostly for either for the health reason or for in case it's difficult for them to come back to St. Petersburg. But most of you have to attend seminars, so would be nice to see you here. And as you might notice, I'm here in the school, room 311. So in case you want to discuss something, we can have an appointment and discuss anything related to corporate finance. We received your projects. Now we are grading them, and we plan to announce the grades for them at the beginning of the upcoming week. Also, some of you had technical problems or were sick during the first midterm exam, and those students will have opportunity to rewrite it. It will be organized in the same way as we had the initial one, and those who are eligible, we will contact them directly in order to plan it, and they will have an access to the system. In this part, we have now we have the second part of our course. In the first part, we discussed mostly the foundational aspect of the corporate finance, main financial mathematics, and now we will apply it to multiple issues, multiple questions that are related to the practice of planning the finance in the corporations. What we have in this model, so the rest of the grade will be constituted from the class participation, which is still in progress, and you can see your current performance state in the gradebook. Also, we will have one more homework at the second half of this module, and we'll have final exam, which will be conducted also remotely. This is the main organizational thing. Do you want to discuss or ask something now on the organizational part?
No.
Will it be online or offline? The exam.
Lectures?
No, the exam.
Exam will be all, I think we will do it online as
Okay.
well.
Thank you.
Anything else? In any case, we already established the means of communication through the MS Teams or email, or now we can also meet in person if necessary. But meeting in person, if you feel that you wanted to do it, better to schedule it. So first contact me or Vladislav, and then discuss. And now having the seminars, you have free time before and after the class to discuss with your faculty the things that you think worth discussing. Good. And in terms of the sharing materials, we will remain the same. Everything will be uploaded in Smart LMS, including the videos of the lectures, slides, and other supplementary materials which are relevant there. Good. I think so. I'm personally happy that you guys will be back here in the school because it's too empty without you. So looking forward to see you all here. And this was the good part, the part. So I hope that your performance will improve So if you haven't worked hard enough, you still have a chance to improve your grades, and there are most of the grade is still ahead, but please take the thing seriously, and we are here. We are very eager to help you to explain anything additionally, just not to if something is unclear to you, make sure you approach us or read the book again or wherever to make things logical here, because everything in our subject is quite makes a good sense, and if it doesn't to you, then we'll try again, and we are ready to explain additional things that we discussed today. In terms of the lecture material, we will approach the issues of the cost of capital of the corporation, and this is naturally related to the risk of the corporation and of the projects that corporation might implement. The agenda of today's class includes 4 main points. First, we will start with the main concept of the cost of capital, which consists of the cost of debt and cost of equity. Then we will focus more on the cost of equity, which is a more difficult component of the cost of capital, and that is why it's worth additionally discussing. Next, we will discuss analyzing the project's risk. So the corporation can be presented as a combination of different projects, and that is why it is reasonable to discuss how the projects can be analyzed in terms of the risk, how we can estimate the risk, and what we can do to mitigate that. And finally, we will discuss the mixed tool in order to estimate the risk. Within the cash flows, it is the certainty equivalent, so the way to adjust the cash flows in order to consider the risk that those cash flows are associated with. The idea that we already discussed with you is this value additivity principle. So the firm can be presented as a bunch of related projects within that firm implements and that firm works with, and the total performance of the firm, total result, its cash flows, its risk is a combination of those smaller projects that firm implements. So if we talk about some big established firms like Google or Ford or wherever firm is, some of the projects that firm has might be very risky, like some venture investments, some research projects. In that case, the chances of failure are quite high, but as the other side of this project, we have in case the project is successful, the outcomes, the revenue, the income that we will receive would be huge. So, for example, if you do some research, in case it's successful, you have an opportunity to have a multifold return on your investment. Alternatively, the most of the well-established firms, they have some projects which are so-called the cash cows of the firms. So if we talk about the Google, it will be online advertisement, which is stable part of the business, which generates main part of the revenue, and this has relatively less risk, and so on. And alternatively, firm can have even less risky investment. For example, purchase some real estate, which will provide lower return, but at the same time, the risk here would be also lower. So those returns are more certain. Those are 3 examples of different projects within the firm, but all of those together will constitute the firm And what we should keep in mind here is that those three projects, they would have different level of risk, and they, if we can do this, it's better to estimate them separately, considering the different level of risk for those projects. We will discuss when we can do it separately. Sometimes it's difficult to estimate them separately, but anyway, we should keep this in mind in order to understand the tendencies within the firm, in order to understand the fraction of assets that firm allocates to the projects of the different level of risk. And graphically, so this is something that you should be familiar with. Last time we discussed with you the security market line when we talk about the capital asset pricing model and efficient portfolio, and we discussed that the optimal set of projects and is can be placed along these straight security market lines. And now we use this idea, and all of those projects that we discussed with you so far within the firm can be placed along this line. So if we talk about some venture projects, very risky projects, they will be somewhere above the average risk of the firm. So this red line is the average risk of the firm, which is resulted in the expected return of this firm. If we talk about some less risky business that the firm has, so if it is less risky, the return will be lower. So firm can, for example, maybe you heard about that big part of the business of McDonald's is a real estate. They try to, instead of renting their property, they try to purchase it to have the stable real estate foundation of their business, which is, and in this example, the real estate part of the business will provide lower return than the main activity of the firm. And here, somewhere in the middle, we will have the main activity of the firm, like manufacturing something or wherever the main focus of the firm is. And for each of them, we can estimate some level of risk. It can, in this case, we will consider the risk in terms of the beta coefficient. Not as we talk about the diversified investors, so we will work not with a standard deviation, but with the beta coefficient here. And here is the slide with one of the foundational ideas within the corporate finance, how we would estimate the cost of the capital. So something to keep in mind, that the cost of capital, this is the cost for the firm itself, but at the same time, it is a return for those who either invest in the firm or borrows money to the firm. And that is why when we talk about the cost of capital, we estimate it in a percentage rate. It's the same technique which we use in order to estimate the return. So firm has to give money back to investors and lenders, and for firm itself, those are costs. But for investors and lenders, those are their return, and that is why this would be the same thing. And we estimate the cost of capital in a percentage rate as a return. And that is why here we have returns. This is first idea. Second idea, which is illustrated here, is the basic way how we split the cost of the firm. We split it by the debt and equity. So equity is something that belongs to the firm and eventually belongs to its shareholders. And debt is something that firm borrows, something that doesn't belong to it. And on this part of corporate financing, firm has to pay some fixed interest. And the total cost of the capital for the corporation consists of these two parts. We can split this for two parts. And the principle here is quite reasonable and straightforward. We multiply the fraction of the corporate value that is invested through the equity. So the fraction of equity divided on the corporate value, we multiply at the cost of equity, plus the fraction of corporate debt multiplied at the fraction of debt within the total value of the firm. And here it is. So this is something that we started from. And another conclusion from this point that we should derive that the capital that firm has, so something that firm operates all its funds, they are not free for the firm. Firm either have to pay dividends or interest rate on the debt, and the main job of financial manager within the firm is to make sure that the capital is attracted in the most effective way, and the firm finance it optimally. So at the same time has a reasonable amount of risk, but the cost of capital should be reduced considering the risk. When we work with this formula, something that we will work with another formula. This is here, this cost of capital is just to illustrate the idea. In next two slides, I will show you the main formula that we use in order to estimate how much a firm has to pay, how worthy, how expensive its capital for the firm is. Important thing here is that we work not with the book values of all of the firm assets, but we work with the market values of it. So if the firm traded on the stock market, there is a market value of its stocks, of its equity, and as a result on the total value, and we will work with that. The same thing is applicable for the debt, because the debt can be issued as a bonds, and bonds, as you remember, are also traded on the open market, and their price can deviate, and as a result, we have to work with the market value of the debt and equity. And return on debt can be estimated as the yield to maturity of the bonds, and return on equity can be estimated with the formula that you already came across to. Maybe you can remind us what is the return on equity. So this line here, how we call this this model, which we apply here. First letter is C, the fourth letter is M. There are 4 letters, abbreviation. The model that we use in order to estimate the cost of equity.
EAPM.
Yes, thank you. I haven't seen who told this, but I'm very thankful to this person. This is correct answer. We use the capital asset pricing model in order to estimate return on equity. Now I saw the question from Saad Ahmed on the meaning of the SML, security market line. I cannot repeat the whole explanation here because we discussed it last time, but in the principle, this is the set of optimal investment opportunity for the investor, and those optimal investment opportunities, they consist of the investment of the risky investment and the risk-free investment. So the combination of the investment on the when we talk about the risk-free, it was treasury bills, and the risky investment were investment on the stock market. And in this case, when we discuss it today, we discuss it from the perspective of the firm, where all investment options of the firm can be also placed along this line. So this is the set of the best investment opportunities for each level of return with the lowest level of risk. And let's go back to the estimating the cost of capital. And one important consideration to keep in mind, so we discussed some considerations already. So as we estimate the cost of the capital by using weighted average of the cost of debt and the cost of equity. But an important practical implication is that expenses, interest expenses and dividend expenses, they are taxed differently. I believe you had courses in accounting, yes, so you should be familiar with the income statement of the firm. Here is example of the income statement of the medical firm Abbott Laboratories, but this is mostly universal structure, so we use it to illustrate the point. And interest expenses, they are above the income before taxes. So the more interest firm pays, the less tax the firm will need to pay. And so this is the feature which is widely used in the tax optimization schemes. So this is something that states, all countries worldwide are not very happy with, but the principle, so some years ago, the main investor as a nation which invests the most of the money in Russia were the Cyprus, even though the Cyprus itself is quite a small firm, but this all happened due to the tax optimization technique. So the big Russian firms, they opened additional legislative body, they opened additional firm on the Cyprus, then firm on the Cyprus borrowed money to the firm in Russia, and this Russian firm paid interest to the firm on the Cyprus, and the point here would be is to reduce the amount of income before taxes for the firm in Russia to pay less taxes here. All money moves to Cyprus, and in Cyprus the income tax, corporate income tax, used to be lower, and firm paid lower tax there, and money went to the shareholders of those firms. Yeah, so the point that I illustrate here is that the interest is a tax deductible thing. But going back to this Cyprus point, recently, last year, I believe, there were international agreements were signed on the avoiding on the preventing countries of having too low corporate tax. And now even on Cyprus, the corporate tax is quite high. It's something like 15%, and these all were made in order to prevent such schemes of reducing the taxes. And going back to our weighted average, to our cost of capital example, so we should consider this something that the cost that goes to the shareholders, so the cost of equity, is not tax deductible, but the cost of debt is tax deductible. And that is why we should include this in our final estimation. And here it is. This is the main formula that we use in order to estimate the cost of capital. So this is called the weighted average cost of capital. This part here is called the tax shield, because as we just discussed, the more interest firm will pay, the less tax it will have to pay eventually. And that is why we should consider this. And in order to consider this in estimating the cost of capital, we have this part in the formula, which is called the tax shield. So this is 1 minus the corporate tax rate. In Russia, it is, maybe you heard, you saw it on the previous slide, but maybe you remember or know it. What is the corporate tax rate in Russia?
20%.
Yes, good. Oh, thank you. 20% in Russia. Russian firms pay 20% corporate income taxes, but there are multiple other taxes that firm has to pay. But in this case, we will focus on this one because this is where we see the effect of the interest reduction of the tax burden of the firm. So this is the first part. And this is the second part, the return on equity multiplied on the fraction of equity within the total value of the firm. Let's consider the example. Here it is. We have, this is the simplified balance sheet of the firm. We have, maybe, excuse me, here is a mistake I made. Let me correct it now immediately. It should be like that. We have a total asset value in the asset side. In the liabilities side, we have a debt and equity. 30% of the passive side is financed. Wait, there is noise on the background. Евгения Чернецова, do you want to say something? No. Oh, you are welcome to say, but if you just forget to switch off the mic, better to do this. So the 70% of the total value of the firm is financed through the equity, and 30% is financed with the debt. Then we apply the formula.
If you have changed the mistake you have said about it, like we can't see right now the demonstration. I don't know, should we right now or?
Yes, you should. Thank you. Thank you for letting me know. Now, is it better now?
Yeah, we can see. Thank you.
Yeah, so here, as we work with the examples from United States data, here I kept the tax rate of 0.21. But no, this is depending on the country that you consider. You should have the corporate income tax here, corporate income tax rate in this part of the formula. So we would multiply the fraction of the debt. So 0.3 is 30 divided on 100 multiplied at the cost of debt and multiplied on the tax shield. 1 minus corporate income tax. In this part, we have the equity, cost of equity. Here we have 15 multiplied at 0.7. When you do it practically in the homework, here we have 7.5 or 15, and here we mean percentage points. If you work here, you can also have 0.075, 0.15. just avoid the confusion here, make sure that you have the right scale at which you estimate in order to have the adequate estimation. No, how you check yourself whether everything is fine. So your weighted average cost of capital should be somewhere between cost of debt and cost of equity. Alternatively, no, not alternatively. Alternatively will be several slides later. Let's revive.
Can you repeat, please, where from did we have the number 0.21 in previous slide?
Yes, it is, let me show you here, is a corporate tax in United States. So this is example from US. Here it is. So this is something that is fixed for the country. And in the examples that we will discuss with you, we will tell you which country we mean. Yes, so you should use the tax rate of the country which we work with. So this is a corporate tax rate in United States in this case.
Okay, understood. Thank you.
It might be omitted, so you do not see the tax rate here because it is the same for each for all exercises for the same country. Good. And in the cost of the weighted average cost of capital consists of the cost of debt and the cost of equity. The cost of debt is relatively easy to estimate as it is based on the obligations of the firms which have fixed interest. But the cost of equity is something that usually is not that straightforward to estimate, and the rule of thumb there is to use the capital asset pricing model. Here you have a reminder of this formula. So we have the return on equity, risk-free rate plus the beta coefficient, and this part is called the risk premium, the difference between market return and the risk-free return. And the only thing that is individual for the firm here is the beta coefficient. How we measure the beta coefficient? The security market line shows the relationship between the return and the risk. This is something that we already discussed with you. So the higher the point on the security market line, more return we demand and higher risk we take. In order to estimate the risk of the equity, we use the capital asset pricing model. Eventually, the capital asset pricing model is presented with a security market line graphically. So security market line is a graphical representation of the capital asset pricing model. Other methods can be employed to determine the slope of the security market line and thus the beta coefficient. Yes, they can be. We will discuss some of them, but the basic one, which is mostly the capital asset pricing model. And in order to estimate the beta coefficient, we use the regression analysis. Last time we estimated the beta coefficient. We had an example to do this when we used the covariance of the return of the stock with the market variance. So I hope you remember that. Then we did it, and this is the same technique as people use in order to estimate the value of the coefficient in the linear regression model. And so in order to estimate beta, we use the linear regression. And here are multiple examples of estimating the beta coefficient for 3 firms. Dow Chemical Firm, Microsoft, Return, and Campbell Soup. Maybe this is just a question to you. Do you remember there was an artist who drew the Campbell Soup cans? So this is artist from United States. He also drew portrait of Marilyn Monroe, I believe, and one of the most famous drawings of him were drawing of the Campbell Soup can. Do you remember the name?
Andy Warhol.
Yes, very good. So this company still exists. They started from these preserved products like soups in the can. And here we use it as an example in order to talk about the beta coefficient. This is something you might discuss on your class in math or statistics or econometrics classes of that kind, though R squared is the estimate of the fraction of the total variance, which is explained by our model. No, in this case, we say explained by the market movement, which are presented in the return of the market within the capital asset pricing model formula. And the thing that we want to illustrate here is that firms mostly remain in the same, like risky firms remain risky because this is their strategy. Less risky firm remains less risky. So firms remain on their risk level over time, but sometimes the things can change, and naturally the particular level of risk will change over time. This is the most risky firm within 3 that we consider here. And we see that it reacts most strongly to the changes in the market return compared to the other firms that we have here in mind. And on the left side, we have a return for the year 2004-2009. On the right side, from the 9 to 2014. And for different periods, the particular risk of the firm might be different, but they mostly remain in the same risk class. And the steeper this red line, the more sensitive return of this particular firm to the changes in the market return. The flatter the line, the less sensitive it is. Here in the brackets, we have a standard error. So this is something that we are about to consider. Standard error shows the extent of the possible beta mismeasurement. So when we estimate it over time, it changes, and in the econometrics, in the statistics, and in the finance, as we also use the tools of those disciplines, we have this principle. So there is some real beta coefficient, and there is the estimation of this beta coefficient that we make over time. And all of those estimations, they cannot be precise by definition because there are multiple factors that affect it, and the way to estimate mismeasurement of the beta coefficient compared to the so-called actual beta coefficient is estimated with a standard error. So higher it is, the more likely the estimate of beta coefficient to change over time, and more volatile it is. And with the standard error, we can, instead of one beta coefficient, we can build the interval having either one standard coefficient plus, one standard coefficient less and will be the confidence interval for the beta coefficient that we can use in order to estimate the risk of the firm equity. The beta coefficient, as we discussed 2 slides ago, they change over time. And in order to illustrate those changes, there is this is the table from the historical, the paper of Sharp and Cooper, which who were first to research this thing. So in each here in the first column we have the fraction of the firm which were in the same risk class for the 5 years. So we have all firms of the market, we estimate their beta coefficient, and then we rank them by 10% quartiles, by 10% percentiles. We rank them, and so there will be some firms in 10s, 9s, and so on. And then we re-estimate it again 5 years later, and out of those firms, so in each class, 35% of firms with the highest betas, the most risky firms, remained in this class after 5 years, and so on. And 69% of the firms remained within either 10 or 9, so hasn't moved more than 1 class up or down. So we see that many firms remain in the same class, but there is quite a big amount of firms that moves, particularly within the middle range. So there are the most risky and the least risky firms, they are more stable in their risk level, and the firms in the middle range of the riskiness, they are more likely to become either less risky or more risky. So this might be related to the industry that they are working in. What we also can do, we can estimate the cost of capital of the firm using the beta coefficient. So the beta coefficient, as we discussed with you how to estimate the beta coefficient for the equity, having the data on the changes in the corporate bonds, we can also estimate the beta coefficient for the equity. And as a result, we can estimate the total beta coefficient. So it's also called the leveraged beta coefficient. So the previous beta that we worked with, they characterize the risk of the firm ignoring its debt level. And here we can, if we introduce the debt, and we will have leveraged beta coefficient, which considers also the debt level of the firm, and this would be the estimate of the riskiness of the firm's assets. Also, we can draw security market line here with the different levels of the beta coefficients. So there is a beta for the debt is always lower than the beta for the equity, because this is the less risky financing in terms of its predictability. It's less likely to change, and you remember that the beta were the estimation of the volatility of asset within the portfolio, and debt is less volatile, and as a result it has lower beta coefficient, and the total beta of the firm is a weighted average of betas of the debt and equity. Also, we can, as this is something that we started from, the operations of the firms, they can be presented, no, they can be considered separately, and we can estimate the risk of different operations that firm engaged into. We can estimate them with different beta coefficients, and here they are. And the principle here would be similar. So this is the principle of the weighted average. We multiply the fraction of assets in each types of operation, in this case in new ventures, in expanding existing business, in increasing the plant efficiency. We multiply each of them into their fraction, and then we estimate the average beta of the company's assets. And as a result of this estimation, we can find the discount rate that would be appropriate for the different fractions of the firm operation. Also, we can estimate the beta coefficient using the different streams of cash flows that firm has. The costs that firm has and income that firm generate. The cost can be, we can distinguish between fixed costs and variable costs. This is something that are usually considered in financial analysis, and multiplying the fraction of each of them into the beta coefficient plus the present value of the assets that firm has in place, we can estimate the beta coefficient for the firm's revenue. The beta coefficient on the fixed costs, as they are certain, it will be close to 0. Then we can simplify the formula, removing the beta coefficient. And here, so the conclusion of this formula, particularly of this part, that we will discuss it in the next class more in detail, but so far this is a principle that we can capture already. That the principle is, the higher the fraction of the fixed costs within the business of the firm, the more risky the firm is. And so this is this makes a good sense. If the firm has to pay the same amount as obligations, as salary, or wherever, the costs which it cannot change, that do not change with the changes in the revenue, the more likely firm to go bankrupt. So let's assume we have some big amount of fixed costs, but the revenue goes down, so we have no money to pay on those costs. Alternatively, then we have more variable costs, the revenue goes down, those variable costs goes down as well. It makes firm more resilient, and higher the fraction of the fixed cost, the higher would be the risk of the firm. So, and the risk is estimated as a beta coefficient. Let's consider some ways that we use in order to estimate the risk of the project. The most important one, the one that we start from, is the discounting. So we have the project which we expect to bring it. The project is expected to bring us 1 million in a 1-year period. We have a discount rate of 10%. We do the discounting, and this is the present value of this cash flows. How we can consider the risk of the firm? we might do, this is basically scenario analysis in a very simple form. We can consider 3 possible outcomes. So instead of 1 million, if the things would go way better, we can have 1.2 million as a possible, as expected cash flows. Or when things go worse, we would have 0.8. Each of those outcomes, they have some probability. And in this case, we designed the scenario analysis in a way that that is resulted in the expected value of the same 1 million. Yeah, so also alternatively, we can have include the probability of having the total failure within the project. So we can also have 10% chances of failing completely and have no cash flows. And if we include this, then we would have the forecast, instead of 1 million, we already have 900,000, which is after discounting will be resulted in this number. What we do here, it's alternative way of estimating the risk. So far, we discussed how to do it with the beta coefficients, which can be resulted in the discount rate. And here we discussed how we can estimate the risk of the projects with the cash flows changes in the cash flows. Okay? And if we have 2 options, it's better to estimate the risk with the changes in the cash flows because it's mostly more accurate. And there are other reasons, yes, that we can illustrate here on this slide. This is the project that we considered. Our initial estimation was that it will bring us 1 million next year. Let's expand this project and assume that it will bring us 1 million yearly for 15 years. The discount rate that we would use here is at 12%. So we discount each cash flows at 12%, and the sum of those cash flows would bring us our present value. And then you remember that we considered failure outcomes that if we include the chance of 10% failure, the expected cash flows would be 900 per year, and this would be the present value that we would receive. In the line 5, we have the difference between this value in the line 2 and this value in the line 4. And you see that here the difference is a stable one. So we reduced initial cash flows by 10%, having the discounted value reduced by 10% as well, which is quite reasonable. But one temptation or one idea that you might have thinking on how to include the risk in your estimation would be to just to increase the discount rate. So we realized that the project at this point we realized that the project might be more risky than we expected, and here we reduced the cash flows themselves. But as we see that the cash flows might be 10% lower than we thought, what we can consider doing, we can consider increasing our discount rate by those 10%. And here we see why it might be suboptimal idea to implement. As the time goes, we see that the power of discounting goes down, and this technique, increasing the discount rate, penalize more distant cash flows significantly. This, no, by the way, this way of adjusting the risk by including additional interest, by raising the interest rate, by raising the discount rate, is called the fudge factor, and this is usually something that we should avoid. It's better to think how we can estimate the risk within the cash flows. If we cannot do this, then we would work with a discount rate, but again, we should do this carefully, because the power of discounting makes all changes in the discount rate very significant in terms of the total estimation of the project's performance, of the project present value. Here we have a summary of something that we discussed in the recent slides. So we can, in DCF, discounting cash flow model that we work with, we have two ways of risk adjustment. We can change, so either change nominator or denominator. Change nominator means changing the cash flows, denominator adding the fudge factor, so adjusting the discount rate. If we can, we change the cash flows, but in many cases it's difficult to do when we talk about unavoidable systemic or market risks that firm cannot avoid. Then we do that, but if risk somehow can be reduced with let's say insurance hedging, or just going to more conservative estimation of the cash flows that we receive, then we can do changes here. We should avoid estimating the risk 2 times. This is something that is important here. What we mean by estimating the risk 2 times, so if we consider some particular risk in cash flows, for example, we included insurance, then we must not include it into the discount rate, so we keep to having it here. Yeah, and this is the final topic that we should cover today. There is a systematic or synthetic view, a synthetic approach of estimating the risk of the project. So synthetic in the sense that we use the discount rate in order to adjust the cash flows for the risks. And this approach is called the certainty equivalence. Point here is the certainty equivalence is the cash flows that after discounting on the risk-free rate gives us the same present value as the one we had by discounting our initial cash flows at the total discount rate. Here is the logical structure. There are some cash flows that we discount using the DCF model to have the present value. Alternatively, we can split this discounting into the 2 parts. We can have only discounting for the time value of the money, which is done by using the risk-free rate in discounting, and also remove all the risks from the cash flows separately by estimating the certainty equivalence. So at this point, we have one step. At this point, we will have two steps. Here, first we have certainty equivalent, and then with the discount of the time value of the money, we would have the present value. Let's look at the example. Project is expected to produce 10 million cash flows, cash flows of 10 million yearly for 3 years. Risk-free rate is 6%. Market risk premium is 8. The beta is 0.75. And the issue is, what is the present value of the project? What we do, we estimate the discount rate using the capital asset pricing model, and then estimate the present value. So these are discounted cash flows, and this is the sum of values here. And next step is to estimate the certainty equivalence. We substitute this column here with the certainty equivalent. How we do this? We estimate the value that after discounting at 6% will give us 89.3. So what we can do here, we would multiply 89.3 for the first year. We will multiply it and 1.06 to have this one. Then we go for the second period. Then we would multiply this at 1 plus 0 at 1.06 squared to have this one, certainty equivalent for the second year, and so on. So we just go. I believe it's easiest way is to work with this formula. So we derive the certainty equivalent out of this formula. Yes, so certainty equivalence in a period T we can estimate it as a C at the period T multiplied at the 1 plus risk-free rate in the period T discounted at the 1 plus risk total discount rate also at the period T, in the same period. So this is a formula to estimate the certainty equivalence. This is the same as here. This part is just the discounted cash flows. Then we multiply them on the 1 plus risk-free rate, and beware that we have to have appropriate time period. Further we go, the stronger would be the deduction for the risk. It's the difference between nominal cash flow and certainty equivalent. which is reasonable because due to the properties of the discount. If here you have a formula that you can use in order to multiply the in order to estimate the difference between the cash flows and certainty equivalence, relational differences in the percentage points. And before that, I draw you the formula that we can work with in order to estimate it. Yeah, so as this part here it is in the same power all the time, we can estimate this fraction once and then multiply, put it in the appropriate power depending on the period that we work with, like it is suggested on this slide. So we can estimate separate discount rate that we use in order to find the certainty equivalence. Good. That is it for today. Let's discuss something, or questions, comments, suggestions.
I have a question.
Please go ahead.
In our schedule in rules, we have a test next week, but is it for all of us or just for students who didn't take the midterm exam?
It's only for those who didn't take it. Yeah, it's maybe due to the technical reasons teaching office put it for all of you, but it is only for those who have to write it now. So those who written it, do not write it again. Anything else?